Hey, welcome back to Valiant PE. Today's topic, elastic longitudinal deformation, also known as elongation. Let's go. Okay, first up, we're going to try a bit of a different setup today. We're going to go all digital. Many thanks to a subscriber all the way from Bangladesh for giving me some feedback on how we could switch up and make our procedure a little better here. So the second thing we're going to do is we're going to go straight into an example. Which we don't normally do. We're going to go straight in. I'm going to solve it all the way through. And then we're going to talk about what makes it a PE level question. Okay? So here we go. First thing, before we start any problem, when we're in an exam and we start a new question, we do our pre-question ritual. So we're going to take a deep breath, read the question slowly. A steel tape for measuring distance is 0.375 inches wide and 0.02 inches thick. It's exactly 50 feet long when supported through its length and pulled with a force of 20 pounds. What will its length be when pulled with a force of 100 pounds? Assume Young's modulus is 30 million psi. You can see we've got our answer choices here, and we've got some imagery. So the cross section of the tape here, just think of this as a regular household measuring tape that pulls in and out. Nothing fancy. And this is what the width and height would be. So the first thing I'm going to do is immediately write what I'm solving for, a length, and its units, which is going to be feet, and I get that from the answer choices. Okay, let's get straight to it. So right away, we know that this is an axial elongation problem, so we write our axial elongation formula, which, rewritten for this specific problem, is P final minus P original, that's our load, times our original length over our cross-sectional area times our Young's modulus. So let's put some values to this. We've got 100 pounds force minus 20 pounds force, zoom in a little bit, times 50 feet. That's our original length. I'm going to go ahead and convert feet into inches. Okay. And our cross-sectional area, which is 0.02 inches times 3/8 of an inch, 0.375 of an inch, and then our Young's modulus is 30 million psi. Okay. First thing we do before we even try to solve it is make sure our units match up. So I'm going to write pounds force times feet times inches. And that's going to be over inches squared in our area. And I'm going to put feet here for my conversion. And I'm going to rewrite Young's modulus like this. All right, now we're going to go cancel pounds force, cancel feet, cancel inches squared. Good, that leaves just inches. So our elongation is equal to 0.213 inches. All right, next step, solving for our total length. So our new total length is going to be our original length plus our elongation. Let's put some numbers to that. Original length is 50 feet. Our elongation in inches, 0.213 inches. Now we need to convert that to feet. All right. Now we can solve. 50.018 feet. Okay, there's our answer. All right. Now, that was pretty straightforward. Let's take a look. What made this question a PE level problem? I'll go through some of the reasons why. All right, number one, and this is going to be for pretty much every problem that we do, it's a multi-step solution. This shouldn't surprise you because almost every problem we're going to see is going to be multi-step. Now, even if the problem is simple, like this one, which it was, multi-step is definitely going to be happening. So first, you see you've got the elongation step here. And then the second big step is knowing that you were solving for a total length, not just an elongation. A third step could be you needed to know that your P in this formula was final minus initial or final minus original. So that's going to be happening in every problem we see. That's going to happen everywhere. Number two, and we've seen this before, is we're going to get tricky answer choices. And again, they're doing this, the authors of the test are doing this because they want to keep you on your toes. They don't just want someone who can plug and chug. But there's a couple sub-bullets here that we need to pay attention to. Units. If we don't keep our units consistent or we didn't convert properly, we're going to get the wrong answer. And here's what I'm talking about. If you didn't do this conversion step, you were going to get either answer A or answer B, depending on if you did the PF minus PO step or not. So if you didn't convert, this is key, you would have got a wrong answer. And look at the magnitude difference here, 50.213 and 50.266 compared to 50.022 and 50.018. Second thing is you need to pay attention to the PF minus, the PF minus the PO step. So if you were rushing, which many people might have done, they probably would not have noticed what this statement means, pulled with a force of 20 pounds. That's an original or an initial force. If you didn't do this step and you blew past it, you're going to solve for the wrong, you're going to end up solving for, this value is going to be wrong. You would end up with answer B. So we see again, tricky answer choices keep coming back to get us. But really the big one, and I think we know this, formula familiarity. It's going to be really impossible for you to pass this exam if you don't know formulas quickly and off the top of your head. If you haven't done enough repetition of elongation formulas or elongation questions, you're going to probably have to go hunting through the reference manual. If you've looked at the reference manual for axial elongation, the section is confusing. There's like 6 formulas there, and you kind of have to go through a derivation. It would have been pretty terrible, especially if you weren't familiar and you're trying to figure it out on the fly. No chance would you have done that in 6 minutes. But the big reason for this example is you needed to know that L in this formula is an original length. That's not listed. This subscript is not in the reference manual. So if you hadn't done problems like this before, you would have just blasted through that or maybe not known what L to put there, and you would have gotten into trouble. So let's go back and take a look here and one last double check. So units would have got you killed here, and then formula familiarity would have gotten you in trouble here. So here are the big things that we can make sure we pay attention to. Units, formula familiarity. Reading the question slowly would have helped us know, pulled with a force of 20 pounds, what that means. And our answer, which we haven't gone over yet, is C. So that's it, guys. This is a simple problem. In fact, probably bordering on a fair too simple for the PE exam. However, it shows the basic concepts. You got to do problems over and over again. You've got to be familiar with what each formula means, and you've got to know where to go to get it in the reference manual if you're going to use the manual at all. And that wraps it up for today. Guys, remember, you don't have to be a genius to pass this exam. Thanks for watching.